Okay, good morning class once again. Today we are going to start with another chapter for class 10th mathematics, which is matrices. As you can see over here, this is a relatively easy chapter and a scoring chapter, okay, as far as your syllabus is concerned. Okay, so let me first brief you about the things that we will be dealing with as far as the first matrix video is concerned. Okay, since this is the first video, we will be dealing with what a matrix is, okay, and why do we use it, what are the different ways in which a matrix is represented, what are the different types of matrices, okay, and what are the different possible operations that we have to deal with in terms of matrices. Okay, so in the beginning, the first video will involve more of theory and more of the generic understanding of what we will be dealing with in this particular chapter. From the second video onwards, we will have a number of questions, okay, and the different solving methods and techniques that we will study. Okay, so let us first have a basic understanding of what a matrix is. Okay, the name of the chapter is matrices. Okay, if you see, the singular word over here is matrix, okay, and the plural version of it is matrices. Okay, so if you are talking about number of matrix, then that word is matrices. Okay, that is the plural word. Now again the obvious question is, what is a matrix? Okay, so here if you read, I have listed down a few explanations over here. A matrix is an arrangement of data or numbers in rows and columns. Okay, so just like you have some numbers, if you want to represent those numbers, there are a number of methods of representing those numbers or listing those numbers or writing those numbers. Okay, but if you want them to be represented in a matrix form, then you have to put them in rows and columns. Please remember, rows and columns. Okay, now there is another way of saying it. It is a rectangular arrangement. Okay, so since you have rows and you have columns, okay, so the overall structure will look like a rectangle. It can be a square also. Okay, so rectangular arrangement enclosed by square bracket, which is this obviously, or parenthesis, okay, which is this. Okay, so these are the different ways in which we will be writing our matrix. Okay, so here are a few examples that I have listed for better understanding. You can have a look here, some examples. Okay, so you see, these are some examples that I have written separated by commas. Okay, so let us take this for example. This is a matrix over here. It has numbers arranged in rows. Okay, so where are the rows? If you have a look at this particular matrix over here, we have the first row, which is called row 1, okay, and this is the second row called row 2. Okay, so this is a matrix which has how many rows? 2 rows. Okay, so first row, second row. Similarly, if you look at it column wise, this is the first column, this is the second column, and this is the third column. Okay, so this matrix overall has 2 rows and 3 columns. Okay, so this is how we understand in terms of the rows and the column representation. Okay, so whenever there are numbers, now obviously these are all numbers that are represented in terms of rows and columns. Now the number of rows and the number of columns will obviously be varying as and when we deal with a number of questions. You will find that the number of rows and the number of columns will keep on varying. Okay, and obviously you see the square bracket. Okay, so enclosing those numbers, we have either the square bracket, or you can see over here, as we have seen, the parenthesis. Okay, so these kind of brackets. Now let us have a look at these examples that we have taken up. 1, 2 row. Okay, so in the first example, if you see, we have first row, we have second row, and we have first column, and we have the second column. Okay, so this particular matrix has 2 rows and 2 columns. Okay, now coming to this matrix, we have 1 and 2 rows, okay, and we have 1, 2, 3 columns. Okay, so this particular matrix has 2 rows and 3 columns. Okay, similarly over here, if you have a look, you have 2 rows and 2 columns. The only reason why I have listed this as well as this over here as examples is because obviously you can see there are 2 major differences over here. One is the use of the kind of brackets. You can have the square brackets also, you can have the parenthesis also. Okay, so this will also qualify as a matrix. Okay, then the second important thing that you note over here is that the individual entries can be in fractions, they can be in decimals, they can be negative numbers, they can be positive numbers, and so on and so forth. Okay, so these are some of the examples. Now have a look at this particular example over here. Okay, the second last example. Now can we call this as a matrix? Okay, so what was the original idea of a matrix? A matrix is an arrangement of numbers in rows and columns enclosed by either this bracket or this. Okay, so now have a look whether this definition is fitting into this particular matrix, or whether this matrix is fitting the definition. Okay, so if you see, count the number of rows, so we will see that it only has 1 row. Okay, whereas obviously it has 1, 2 and 3 columns. Okay, so the representation is in terms of rows and columns, and there is a square bracket also, so we can call this as a matrix. Okay, now what particular type of a matrix, all these things we will be discussing later on in this video. Okay, now similarly over here, if you have a look, this has 1, 2 and 3 rows but only 1 column. Okay, so this is also a matrix. Okay, so these are some of the examples of the matrices that you will find. Okay, now when we study for a particular matrix the number of rows and the number of columns, you see there is a term that is used for that particular matrix in terms of the rows and the columns. It is known as the order of the matrix. Okay, so if you have a look at this example that I had shown over here, now we have already counted that there are 2 rows and there are 3 columns. Okay, so in small letters, in small numbers, by the right hand bottom side of it, if we write 2 by 3, okay, so this representation on the right hand bottom corner of a matrix is what is known as the order of that particular matrix, and that order will give you 2 pieces of information. One will be number of rows, which will be given by the first number, and the second number will show you the number of columns. Okay, so for this particular matrix we will obviously write 2 first and then 3 in the second place. Okay, separated by what is known as the multiplication sign to you, but then this is not called multiplication over here. This will be called, this will be read as you can see I have written over here, the order of the matrix is 2 by 3. Okay, read as, so you will read it as 2 by 3. You will not say 2 into 3. You will say 2 by 3. Okay. The reason why there is a multiplication sign over here is that if you actually want to determine how many total elements or how many total individual entries are there in a matrix, then you can obviously multiply the number of rows with the number of columns. So you see 2 multiplied by 3 will give you how much? It will give you a number 6. Okay, so if you count 1, 2, 3, 4, 5, 6, there are 6 individual entries that are there, or 6 individual elements that are present in this particular matrix. Okay, so the order of the matrix gives you a lot of information, important information about a particular matrix. It tells you how many rows are there in the matrix, it tells you how many columns are there in the matrix, and when you multiply the number of rows and the number of columns, you will get what is known as the number of individual elements or the number of entries in a particular matrix. Okay, similarly, if somebody asks you about if you are being asked how many individual elements are present in this particular matrix, so you can see without actually going ahead and doing the multiplication, you can see 1, 2, 3, 4 entries are there, 4 individual entries are there. You can guess that by applying the same logic that I have explained in terms of the order of the matrix. So what is the order of this particular matrix? If you see, I can write the order of this matrix as 2 by 2. Okay, because there are 2 rows and there are 2 columns. Okay, so 2 rows and 2 columns, 2 by 2, 2 into 2 will give you 4. Okay, so there are 4 individual entries. Similarly, you can do it for the remaining matrices also. Okay, so till now what we have discussed is what is a matrix. It's a representation of number in terms of rows and columns in a particular order, enclosed between particular kinds of brackets. Okay, then we have studied rows and columns. How do we write rows and columns? And row by column is what is known as the order of a particular matrix. This order of a matrix is very important when we will study the matrix multiplication. Then you will actually realize the importance of the order of the matrix. Okay, so now let us move on to the general representation of a matrix. Okay, these were the individual particular examples that I had taken. Okay, so here is what we are representing in terms of the general idea of a matrix. Okay, those were individual examples that we had taken. Now if you want to represent a matrix generically, okay, where you actually don't know the individual entries, so how are you going to represent it? Suppose A is a matrix. Okay, so this any matrix will be represented with a capital letter. It can be A, B, C, D, whatever. Okay, so there's a matrix A. Okay, and what is that matrix actually in terms of the entries that we have? You see, I have written the general version: A11, A12, A13. Then A21, A22, A23. Now what are these? What is this 1, 1, 1, 2, 1, 3? So if you see, the first number represents the row and the second number represents the column. Okay, so when we talk about A11, okay, this particular entry, it is very obvious to our mind that this entry is present in the first row and it is also present in the first column. Okay, so this 1, 1 actually represents the first entry in the first row and the first column. Okay, similarly, when we talk about this particular entry, okay, this 2 represents the second row. As you can see here, this was the first row and this is the second row. Okay, so 2 comes. This 2 denotes the row in which this entry is present. So this entry is present in the second row, first row, second row. So it is present in the second row. Which column is this entry present in? It is present in the first column. Okay, so we have this number 1 over here. So I have listed down over here. A11 represents an entry in the first row and first column. Similarly, 21 will represent entry in the second row and first column. And similarly, if you want to select, let's say for example, this particular entry, it is present in the second row. Why second row? This is the first row, this is the second row, and then first column, second column. So this entry is present in the second row also and in the second column also. Similarly, so generally if you want to represent, it will be represented as the individual elements can be generally represented like this: A, small I, small j, where I is the row and j denotes the column. Okay, so that will be the general understanding. Now we are going to come to a very important aspect, a very important concept that we will have in terms of the matrix and the determination of the kind and the type of the matrix. We have what is known as the principal diagonal of a matrix. Okay, diagonal word, if you recall, if you have a rectangle, say for example, okay, this is one diagonal and this is another diagonal. Okay, so there are two diagonals over here. Similarly, in terms of the if you want to have a square, you will have suppose this is a square, you will have one diagonal over here, you will have the second diagonal over here. Now talking about matrices, if you see, let matrix A be equal to, now this is the matrix that is given. How many rows are there? 1, 2, 3 rows are there. How many columns are there? 1, 2, 3 columns. So 3 rows and 3 columns. So the order of the matrix A is 3 by 3. Okay, and obviously the total number of entries are 9. So what are the possible diagonals that are present in this matrix? So one obviously will be this, the other one can be this. Okay, so although there are two diagonals in the matrix, okay, but then we have to talk about the principal diagonal or the leading diagonal. As you can see over here, these are the terms that are denoted to that are used to denote this particular diagonal. Now what is the significance of this particular diagonal and why do we ignore this particular diagonal is because you see we always start from the first entry of the matrix, which is this entry 7 over here. If you can see, the first individual entry of any matrix will be present in the first row and the first column. Okay, so this is the first row and this is the first column, so the very first entry of this matrix is present over here, not here. Okay, similarly, what is the last entry of this particular matrix? The last entry is over here because it is present in the third row, which is the last row, and the third column, which is also the last column. Okay, so these entries in a straight line extending from the first element to the last element of a matrix, if you put these numbers together, these numbers or this particular line is known as the principal diagonal of any matrix. Okay, so what are the elements of the principal diagonal? If you see, we have 7, we have 0 and we have 5. Okay, so these are the elements of the principal diagonal of a matrix. Okay, clear? Okay, so now let us have a look at some of the different types of matrices that you will find as and when we move along with the calculations involving the matrices. Okay, so you should be able to by looking at the matrix, able to analyze what is that particular type of the matrix that you are dealing with. Okay, so let us start with the very basic one. Number 1, it says row matrix. Okay, so as the name suggests, it will only have one row. Okay, so matrix having only one row, and I have listed one example over there. If you see, it's a matrix which has how many rows? It only has one row. If you see over here, this is the only row present. There are no subsequent rows below the first row. Okay, although you can see that there are 3 different columns. These columns could have been 4 in number, 5 in number, or maybe just 2 in number. Okay, but the essential condition for a row matrix is decided by the presence of only one row. Okay, so as long as a matrix has only one row, it will be called as a row matrix. Does not depend upon the number of columns. It can have 2 columns, 3 columns, 4 columns and so on, but the number of rows in a row matrix will be 1. Okay, similarly for the column matrix, matrix having only one column. Okay, so again this is an example in which you can see there is only one column present. There are no subsequent columns present. Okay, although again, once again, the number of rows is irrelevant here. There are actually 4 rows over here. There could have been 3 rows, there could have been 2 rows, but the deciding criteria here is one column. So is there one column present? Yes, there is only one column present. So this matrix is a column matrix. Okay, and if you remember, before we go ahead, if you want to write down the order of the matrix that we just studied, in this very first one you can say that this has one row and it has 3 columns. Okay, so the order of the first matrix is 1 by 3. Similarly, the order for this matrix is 1, 2, 3, 4 rows are there and 1 column is there. So very carefully you write 4 by 1. Okay, please remember, in the order of the matrix, the first entry will always denote the number of rows and the second one will denote the number of columns, and the order of the matrix is to be written on the right hand bottom corner of the matrix. You can put, if you want, you can put this in some small brackets over here like this. Okay, so this is what you have. Now coming to the third one, which is a square matrix. As the name suggests, its structure will be like that of a square. So the lengthwise and the breadthwise they will be equal. Okay, so what will be equal? You have number of rows equal to number of columns. Okay, so a very basic example over here I have listed. Now this particular matrix has 2 rows and it has 2 columns also. Okay, so what is the order of this particular matrix? It is 2 by 2. Okay, so the number of rows as well as the number of columns, they are equal. Therefore this matrix qualifies as a square matrix. Now coming to the rectangular matrix. Rectangular matrix will not have, if you notice over here, this particular symbol shows not equal to. Okay, so number of rows and number of columns, when they don't match, then you have a rectangular matrix. Okay, so one example again that I have listed over here, you can see that there are only 2 rows present but there are 3 columns present. Okay, so the order of this particular matrix, if you want to write, you will have to write 2 by 3. Okay, so number of rows and number of columns don't match. Similarly, you can also have a matrix of the order 3 by 2. That will also be a rectangular matrix. Okay, whereas a matrix of order 3 by 3, 4 by 4, 5 by 5 will be always a square matrix. Okay, so these were the first few. Now coming down to the fifth entry over here, which says the 0 or the null matrix. So again, the name itself is describing what kind of a matrix this could be. This is a 0 matrix or a null matrix. So all the entries, all the individual elements of such a matrix will be 0. Okay, so 0 0 0 0 0 0. There are 2 rows and 3 columns. If you see over here, all entries are 0. Number of rows and number of columns are not important here. Regardless of the number of rows and columns, what you have to look for is whether all the elements are 0 or not. Since all the elements here are 0, it can be called as a 0 or null matrix. But if suppose that I change this entry and make this as 1. Okay, if I change this particular entry and make it 1, then can this matrix be called as a 0 or a null matrix? No. Okay, so please remember, all the entries have to be individually 0. Okay, so this is a 0 or null matrix. Now coming down to the sixth one, which is the diagonal matrix. If you remember, you recall just a little while back we had discussed what a principal diagonal of a matrix is. Okay, so it stretches from the left hand top corner to the right hand bottom corner. Okay, so a diagonal matrix, if you read, it is a square matrix with all non-diagonal elements 0. Okay, non-diagonal elements, and the important word here is, I have underlined, square matrix. Okay, so if you have a look, there are 2 examples that I have listed. This first example is that of a matrix which has the order 2 by 2. There are 2 rows and there are 2 columns. Okay, similarly in the second example we have 3 rows and we have 3 columns. Okay, so the number of rows and the number of columns are matching in both. Okay, so both these are square matrices. Okay, now coming to the definition of diagonal matrix, all the non-diagonal elements should be 0. Okay, now so for finding out the non-diagonal elements, first find out what are the diagonal elements. Now by the word diagonal elements, we refer to the principal diagonal. Okay, so in the first one, you can see that these are the diagonal elements. Okay, so what will be the non-diagonal elements? These 2. Okay, so these 2 non-diagonal elements, check whether they are 0. Yes, they are 0. Okay, so non-diagonal elements are 0, so this qualifies as a diagonal matrix. Similarly, in the second example that I have listed, it is also a square matrix, so check whether the non-diagonal elements are 0. So first you single out the diagonal elements. These are the diagonal elements. Okay, leaving the diagonal elements, all the others are non-diagonal elements, so these non-diagonal elements are 0. Therefore even this matrix will be called as the diagonal matrix. So continuing, we have the 7th type, which is unit or identity matrix. Okay, unit is 1. Okay, unit means 1. Okay, so unit or identity matrix, it will be a square matrix with all diagonal elements as 1. Okay, please note, take your time in analyzing what is written, and because you will have to eventually remember what is an identity matrix. It is a square matrix in which all diagonal elements will be 1 and all non-diagonal elements will be 0. Okay, so obviously the moment you understand the definition, you visualize in your mind that such a matrix will have only ones and zeros present in it. Okay, there will be no other numbers apart from ones and zeros in an identity matrix. Okay, and there are particular positions where there have to be ones. Okay, all diagonal elements will be 1. Okay, so again, what are the diagonal elements? You can see that these are the diagonal elements. Again, we are talking about the principal diagonal, not this diagonal. We are talking about this diagonal. Okay, so all these diagonal elements are 1 and all the non-diagonal elements are 0. Okay, so such a case gives you an identity matrix. Okay, suppose, now just to confuse you, suppose I put a 1 over here. Okay, suppose I change the scenario like this. Now have a look whether this matrix is satisfying the definition or not. All diagonal elements should be 1. So all diagonal elements are 1. Okay, so one part is okay. But are all non-diagonal elements 0? All non-diagonal elements? No. This is a non-diagonal element and it is not 0. Okay, so then this matrix cannot be called as a unit matrix. Okay, so we will have to go back to the original matrix. This is a unit or an identity matrix. Okay, so you will have to go through these, sit down for some time and go through these, write down some examples on your own also. Then the moment all this gets into your head properly, then we will begin with the questions. Now coming to the last but very important part, we have equal matrices. Okay, so whenever two things are equal, whenever we talk of equality, there are two or more things that are being compared. Okay, so equal matrices, there are two important conditions for two matrices to be equal. Number one, order of both matrices should be same. Okay, their orders should be same. Then the second point is their individual corresponding element should also be same. Okay, so now having a look at the example will explain it better. I have taken up two examples. Let us have a look at the first example first. We have two matrices A and B. Okay, matrix A has entries 2, 1, -1, 5. Okay, so if somebody wants to write the order of this particular matrix, he will write 2 by 2 because there are 2 rows and 2 columns. Okay, similarly for the B matrix also you will write 2 by 2 because there are 2 rows and 2 columns. Okay, so is the order of both matrices same? Yes, the orders are same, 2 by 2, 2 by 2. Come to the second condition, are their individual corresponding elements also same? So individual corresponding element means if we take the first element of this, we will have to see the first element of the second matrix also. Are they equal? Yes, they are equal. Okay, similarly the second entry over here and the second entry over here, they are also same. Third also same, fourth also same. So the individual entries are same. So both conditions are satisfied, therefore we can write matrix A equal to matrix B. Now the reason for selecting another example over here is to tell you what are the situations in which you can have non-equal matrices or unequal matrices would be the better word. Okay, so you see matrix A is this matrix and matrix C is this matrix. Again, let us check the first condition. So for first condition we need to write the order. So the order here is 2 by 3 because there are 2 rows and there are 3 columns, whereas here you have again 2 by 2. Okay, so obviously the orders are not matching. The first condition gets nullified. The first condition is not satisfied. Therefore we cannot say that matrix A and matrix C are equal. In fact, they are unequal. Okay, so that's one way to look at it. The other way also is if you have a look at the second condition, obviously we cannot match each entry of matrix A with the corresponding entry of matrix C, because although you can match this 2 with this 2, this 1 with this 1, there is nothing for these 0 and 5 to be matched. Okay, so basically you don't have the same number of entries in both the matrices. Okay, so they cannot be equal. Okay, so these were the different types that we had to discuss. Now, based on what we have discussed today, I hope that you revise the entire portion. Have a look at the videos over and over again. If there is any problem, please ask, because now on from the next video we will be discussing with some of the operations like addition of matrices, subtraction of matrices, and then eventually followed by multiplication of matrices also. Okay, so we must have a clear understanding of these things. Okay, thank you class.